All right, hi everybody. We're working through the Diploma prep material. This is the chapter on exponents and logarithms. And we're looking at some word problems now here. Now this question is kind of an interesting one. A sports car depreciates at a rate of 14% per year, okay, and was bought for $60,000. How long will it depreciate to $18,000? Okay, so we're going to model this, okay, with our y is equal to AB to the t over p. Now that's an equation that's given to us at the beginning, at the top of this page up here, actually, right there, and then they describe what this is all about here. Now, take a quick look at this. To fill in the information here, what's going on here is the car is eventually going to become $18,000. So that's our y. That's kind of where this thing ends up. The a is where it starts, okay? These 60,000 here. Now, that's going to be where it starts because when time is equal to 0, b to the 0 will be 1. That's just going to reduce down to a. So this is the starting value. Okay? The p is the period of this growth, or the period of this change here. Now, this thing says that we're losing 14% per year. So we're working on this on a yearly basis here. So the p is going to be 1 here. So this will just end up being t over 1, which is just t. But the real issue with this question is what goes here. It is very tempting to want to put 14% there, or put like 0.14 here. But that's a misunderstanding or a misreading of this problem here. To put 0.14 here would imply that this car is losing 86% of its value. Okay, because what you got to know about the way this model works here is that what goes in here represents the fraction that you're left with at the end of your period. Now, we are not left with 14% of the value of the car. We are losing 14% of the value of the car. So what are we left with? Well, we are left with, just even if you have to think about it as what's 100% or 1 minus 0.14. Now, because of this calculation, I often like to use, in a model like this, and I'll just write it over here, I often like to use A equals P times 1 plus I to the end, the compound interest equation. Okay, because it really is a population growth model, and it separates out the 100% and the interest rate, or the growth rate, quite nicely. But anyway, I know a lot of people aren't specifically using that, so we're going to talk about it in terms of this formula. So that b in this case is going to end up being 0.86. I am left with 86% of the value of the vehicle. Okay. Because this is losing that, and another way to think about it here is this has to be a decay model. That base has to be less than 1 for this to work. Okay, in any case, now my goal is to figure out what t is. Okay, well, to get the t here, I'm eventually going to take the log of this equation, but I'm not going to do that right away because I've got this coefficient here. So I'm going to divide first to get 18,000 over 60,000 is equal to 0.86 to the t. Okay, now what I'm going to do here is I'm going to simplify this right here because it's like I've got all these thousands and stuff here. I'm going to make that a little bit easier for me to look at. And when I convert that, I'm going to get rid of the zeros here, and I'm going to end up with 18 over 60. That's going to end up being 3/10 is equal to 0.86 to the t. That's just a little easier to work with. Now I'm going to take the log of both sides. So this will end up being the log of 3/10 is equal to the log of 0.86 to the t. I'm going to bring the t down. That was the whole point of taking the log, was to get the t out of the exponent. And now I'll divide. Now I'll get the log of 3/10 over the log of 0.86 is equal to t. And in this case here, I'm going to get 7.98, blah, 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 goes on and on and on. So what does that mean in terms of time? Well, that means the 8th year. So when how long will it take to depreciate to 18,000? 8 years. Now, even if this had been 7.12, I would still round that to 8, because what this is telling me is that 7 years have passed, 7 complete years have passed, and I am a fraction of the way through the 8th year. So even if this is only 0.12, even if it's only like halfway through January in that 8th year, you are still in the 8th year. And that's kind of how we deal with the time there. It's a little weird.